So to the final presentation of the day. This is the winner of the office category. We're in Stockholm. Please welcome 3XN. Congratulations.
All right, thank you. Forskan. Forskan is a 25,000 square meter life science hub in Stockholm, Sweden. But it's also a building shaped to enhance its precinct and encourage knowledge sharing amongst its like-minded tenants, while also encouraging social interaction within the public domain. It sits at the nexus of a new master plan and an existing health and hospital precinct and research precinct in Stockholm. And it's at the hinge point of this new green spine that runs through the master plan that binds the new master plan and the heritage, or I should say the older portion of the research institute, so this established green space. It's a building in the round within a square site. So in doing that, it actually frees up its edges and increases the amount of activation within the precinct. So it's a building that actually gives back to its urban environment. This is the image actually of the built image where you can see how the building starts to taper downwards towards the ground level, actually increasing the amount of urban space around the building. And as the concentric rings or concentric floor plate rings step out 1 meter as the building ascends, it also provides a natural or passive overhang, blocking that really high sun in the summer. And then the vertical striation of the facade, the vertical lamellas actually starts to block the really low sun that you get in Stockholm as well. So you can see it's a building that's actually a good neighbor. It's a dense environment that starts to taper, creating an increasing activation around the edges. So that's an intro to the building. But really the drivers of this project were creating that urban life and connection that we just talked about, creating a hive of activity, increasing natural daylight, especially in a place like Stockholm where it's needed, encouraging collaboration, and then of course sustainability with any of our projects is extremely important. So this building, a round building on a square site, in order to increase the amount of public amenity, urban amenity, the building tapers, as I mentioned earlier. That creates a series of pocket parks. It also allows for an entry and an increase of the amount of green space that comes in from the master plan, and the green spine allows that to flow through the building and then connect to the other site, which is also connected to the metro. You can see how the building actually sits in its site. Again, an unassuming form, quite simple in its articulation, is doing quite a lot for the surrounding context. Again, opening up vistas, providing more natural daylight within the area. That green space, the urban space, is then continued actually through the levels of the building with simple indentations around each level to create outdoor space. And then at the top of the building, a publicly accessible roof garden that also helps with biodiversity.
We're just about to step inside the building, but just to finish on the exterior, those terraces are also about an extension of the workplace. It's a sealed box, it's a laboratory building. So it's about the extension of the workplace and creating fresh air for each of the tenancies. Encouraging collaboration. In our designs at 3XN, we believe architecture shapes behavior. Everything about this building was encouraging the scientists to come together in the heart of the building, the atrium, and creating that social spine, that visual connector as you enter the building for the 1,700 occupants, as well as the communities and the visitors at the ground floor, bringing them up into the building to use the spaces. recognizing that innovation does not happen in isolation of the spaces, just the laboratory spaces, but it was also about those central collab social spine areas. There is a 12-meter high artwork which connects the top of the atrium down to the Science Museum and the interactive exhibition for the Education Centre. At ground floor, it's almost 100% active frontage. There's no basement as such because of the tunnels and the rail link underneath, and there is no cars on the site. There's a small end of trip entrance for a few bikes, but other than that, everybody arrives by foot and public transport. At level 1, we have conference facilities, industry events, and co-working space, as well as the views down to the museum. The typical floor plan is radial in form with those collaborative spaces around a cantina, as well as a 3-meter wide zone which offsets, similar to the external form. The central space to the floor plates are very deep, but they are used for the technical boxes, and then the radial form of the floor plate becomes the write-up spaces beyond. Typically, you could occupy the floor plates in up to 6 tenancies, but of the 15 large tenants that have occupied the building, mostly are either single floors or 2 to 3 tenancies on a particular element. And you can see here the cross-section, how that external form and relates to the internal form, with maximizing the daylight with the connecting social spine. So the public is invited into the building. Then there are semi-private spaces and private spaces, and you can see here that the public also goes up to the roof terrace, as well as a restaurant and a lounge on the upper occupied floor. So it becomes a city attractor. Natural daylight is really part of the scheme as well, and we have a number of different uses through those spaces. Direct sunlight is blocked from the outside by the stepping volume, but from the inside there is a large 28-meter diameter skylight which allows natural daylight down into the spaces. Internally, the spaces are arranged around the full-height atrium to bring daylight down into the building, but also allow visitors to glimpse up from the public areas. Each of the office spaces is actually set back 3 meters from this internal atrium to, in essence, become almost like an internal veranda to the atrium itself, to these protected technical boxes that sit behind, with large trees and perimeter planting thriving in the daylight space, and it also softens the edges and works well with the natural materials. From a sustainability perspective, there's a gold standard at Sweden's, which is Sweden's highest sustainability accreditation. It's LEED Platinum and WELL Gold. But we also wanted to think about things beyond the compliance approach. So passive shading, solar radiance control, which also reduces the extent of plant rooms, the operational costs, the operational carbon. The step form shades the summer sun, but allows light in the winter, which is essential for the short days in Sweden. There's a kit of parts approach to almost everything, including the laboratories themselves, where components have been designed for easy assembly and disassembly. Of course, there's no cars, which is easy in terms of encouraging the users to not rely upon anything other than your self-propelled public transport and so on. There's rainwater harvesting for all the bathrooms, as well as the irrigation. And the internal temperature is regulated by heat pumps, which utilizes energy stored in the ground, helping to cool the building in the summer, as well as heat it in the winter. At roof level, we've got a full accessible amenity space with outside kitchen, landscaped areas, and a PV array. Biodiversity with planting, beehives in the kitchen garden for the restaurant. Materiality is light, tactile, with wood and natural stone used on the inside and the outside. Swedish building material assessment tool was used, which is a requirement for sustainable construction. And local stone was sourced from the Gotland island, and the natural timber was a impregnated species from Arnhem in the Netherlands, which has a 50-year warranty. To end, the building is seen as a landmark in this central location where it interacts with the city and creates a new collaboration environment. In addition, sustainability was at the front and center, and the building will provide optimal daylight, social zones, and sustainable settings for everyone that works there. Thank you.
Sorry, maybe you mentioned, but I couldn't catch it. It's a private building, right? I mean, privately owned building.
Yes, that's correct.
Why the roof is open to public? I mean, is there any regulation on that matter, or
No,
just a...
it's not a regulation. It was important for the developer to actually try to increase public amenity within the area. So opening the ground floor to a science museum, 2 cafes, and then extending that public space to the rooftop. So it wasn't a requirement, it was something that the developer wanted to do. They wanted this building to be about the community, not your typical lab space that's closed off without any visibility or access.
But there's no service on this rooftop, right? I mean...
There's a restaurant at the top
There's a
level,
restaurant as well. Okay.
and then you access the
The
terrace
rooftop,
from
yeah.
there.
Okay.
Yeah, can you tell a little bit more about the structure of the building? Because, you know, it's go like this, and then there's a cantilevered floors.
Yeah,
so how are you dealing with this? Because it looks like in wood, but I'm not sure it's all wood construction.
No, we did investigate a timber frame building, which the laboratory tenants were very nervous about because of vibrations. In addition to that, you would have seen on the cross-section, there's pretty much no basement because we are building directly over the top of a significant rail interchange plus a road tunnel. So we had to use concrete, unfortunately, but that allowed us to sort of keep the floor-to-floor heights as minimal as possible, instead of increasing it and potentially losing space.
But the external elements are in wood.
Yes.
Yeah, this is all wood construction. Yeah, it's good. Yeah.
External element means, I mean, external parts after the concrete is wood, all the part, or the
So
slabs are...
The slabs are concrete. So it's a concrete frame building with
Just-
timber
just
clad
the cladding,
internally
I mean, just the
and
cladding.
externally, yeah.
Got a question which is possibly not specific to your project, but you've exemplified it, which is the idea of the large atrium. And when you look up at an atrium, you hardly see anybody. It's not a kind of communications method, but you see the artificial lighting against the blue sky. Now, is that something you looked at closely, the relationship between artificial lighting at the lab level, the ones you have in the ceiling, and the daylight that's pouring in?
Yeah, it was important to make sure that we're getting daylight from both the external area, external facade, which is typically your write-up area. The lab spaces themselves have a more controlled light, artificial light within the center space. And then between the atrium and the labs, you have that informal area.
Could you put up the plan?
Yeah, would love to, actually. Trying to go back. So I'll show this image first, because I think this demonstrates actually what we were trying to do with the concentric floor plans. The idea that you have a multi-story void within a building is typically just that wow moment, and you don't get anything else from it except daylight. In this instance, because the floors are cascading away, even though you may be separated on multiple floors, you're still getting that sense of community by being able to see what's happening on the floors below. Also with the stair, which is the vertical connector, it also acts as a social connector. So at the base or landing of each one of those stairs is where we have that commingling area, that informal meeting area. So that's getting natural daylight into the space as well.
Do you have any informal space on the staircase when you're actually on the stair, which is nice?
No, yeah, not on this project. However, the nice thing about a stair versus a lift is you can take your time. When you're walking on a stair, you typically will continue the conversation that you started off the stair. And in that space, you'll actually see people utilizing the stair as, again, another means of informal meeting. But it's directly opposite the gathering space, the informal coffee area.
Yeah, the cantina is the extension of the stair at each level.
Can I ask one technical question? You mentioned impregnating the timber with what?
There's a company in the Netherlands, in Arnhem, which has developed a product. It's a natural chemical that they do to provide a 50-year warranty to the timber. It's called a koya.
Have you got a name for it?
It's called a koya.
Quaila?
Yeah.
Is that the chemical?
No, I think that's the product that they've developed.
What's the chemical?
I'm not sure.
Okay.
I have a question about the skin, building skin and sustainability. You've talked about shading, and it's a circular building where the treatment is the same in all directions. Secondly, I understand this building is in Stockholm, so I'm assuming most of it requires no shading. And then the form itself is self-shading, because as it steps up, it shades from below. So I'm a little bit confused that why a building in Stockholm requires this kind of application of sustainability and shading.
So in Stockholm, like anywhere in the world, you still need to shade a building. There's still thermal and energy needs that you have to meet. You still have a high sun in Stockholm, and actually have that for quite a bit of time during the summer months. But you also have glare in an office building. And then the vertical lamellas, because the sun is actually quite low during parts of the year and tracks almost, it's not 360, but further east and west than it would in a lower portion of the world. You still have to block that really low east and west sun further around the building. So that's the reason for the continuous wrap of the facade. But the high sun's still important. You still need to block it.
Okay, thank you.
We did investigate, maybe to also extend, I think you were meaning about how if the facade kind of relates to the orientation. I'm not sure whether you meant that. We did look at that, and we looked at how do we optimize the material use, the depths of the lamellas and the spacing of those, create the look of a building in the round without using curved glass. I think that was one of the things that was really important to the client, that it was a cost-effective solution, and there was a simplicity to the architecture, so we weren't overcomplicating it in the vertical axis as well as the horizontal.
Because I would have assumed there's almost, and I could be wrong, that there would be not much sun in north, or to cause either heat or glare.
There's still sun. The radiation levels are lower. So the solar radiance, the intensity of the sun isn't as severe, but you still have all the same issues that you would anywhere else in the world in terms of trying to block the direct sun from coming in, but you want to optimize the daylight, which is what this facade is doing. You still have floor-to-ceiling glass, but you're blocking that direct sun. And then also with the timber, it's about creating a warmth to the building, something that feels like it belongs to the park setting, as well as something that's inviting visitors in.
I think one of the interesting things is that you've achieved a uniformity with the facade that doesn't give you any solar orientation at all. And that is a kind of architectural move, not necessarily one to do with daylighting specifically or sunlight. Would you like to comment on that?
I would agree. The idea of trying to find that optimized depth in order to do all of those things we just talked about is obviously important. And then the consistency of the facade to help accentuate the building as well was important. And it is doing its job. It's not tuned per elevation, but it's tuned for the buildings. And sometimes buildings don't have to try to do too much in order to be successful.
Thank you.
Thank you. Thank you very much.